Today I'll be solving problem number 5, which reads, solve the following system of equations, word problem using matrices. Jimmy has 28 pieces of fruit. The number of apples he has is 4 less than the combined total of pears and bananas. He has twice as many apples as bananas. How many apples, pears, and bananas does Jimmy have? In the equation, there are 3 parts that need to be broken down into systems of equations. These are Jimmy has 28 pieces of fruit, shown by apples plus bananas plus pears equals 28 in total, followed by apples, or the number of apples he has is 4 less than the combined total of pears and bananas, shown here by pears plus bananas minus 4 equals apples. Last, he has twice as many apples as bananas, which is 2 apples equals bananas. Now, the objective of this is to create a 3 by 3 matrix, but this cannot be done in the current system of equations state, therefore they must be converted. So in order to do this, it must be made so that all of the variables are on one side of the equation. Now, in the process of making apples work, it stays the same, there's no change. In the process of making the second system work, the number 4 must be added to both sides of the equation, and a must be subtracted from both sides, giving you pears plus bananas minus apples equals 4. Lastly, on the bottom one, b must be subtracted and made 2a minus b equals 0. Now, from this state, you must take the coefficient of each variable and move it into the matrix, which gives you a 3 by 3 matrix of the coefficients 1 all across the top, -1, 1, and 1, and 2, -1, and 0. Followed by a second 1 by 3 matrix of the solutions on each of the converted systems of equations, resulting in 28, 4, and 0, with a third matrix to show where those should be, but they're not next to the 3 by 3 as technically they are still on the other side of the equal sign. What must happen in order to continue the problem is for the 3 by 3 matrix to be moved over to this side of the equation, as the 1 by 3 cannot, as they're all solutions. Therefore, what must be done is a multiplication by the inverse of the 3 by 3 matrix to both sides of the equation. Now, as this side has the normal version of the 3 by 3 matrix, these two cancel out, resulting in there being no 3 by 3 matrix on this side of the equation. However, when followed down to here, the inverse 3 by 3 matrix successfully converts itself over to this side of the equation so that it's next to the solution 1 by 3, leaving this 1 by 3 matrix on this side, which can then be disregarded as no longer a part of the problem. What must then be done next is the solving of the 3 by 3 matrix through the cross multiplication formula, where you would take the first 2 columns and move them out to the side of the 3 by 3 matrix, resulting in a multiplication up on all of the variables and down on all of the variables, resulting in this. This is a very ugly 3 by 3 non-inverse matrix that then must be multiplied by the solution 1 by 3 matrix in order to bring about the final solution of the equation, which is a 1 by 3 matrix of 12, 24, and -8, which then interpreted means there are 12 apples, 24 bananas, and 8 pears. That's number 5. Thank you very much.